all the hackers. We are very lucky to have our head of engineering and co-founder, Mauro Toscano, here to lead our first technical session. So this is your chance to learn and ask questions as well. So drop stuff in the chat, and we can probably bring people on stage as well. But Mauro, we'll let you go through your presentation first, and then depending how much time we have,
thanks.
Do that.
Thanks, Boris, for hosting and for the presentation. So the idea was to give an idea of a line. You probably know the project, how to use it with your own application. So I will start by saying things that you might already know, but the objective of a line is to reduce proof verification costs and other networks. So to build now in the hackathon, what you can build is any application that offloads computation on any of the provers that we support, and then use the results on Ethereum to take an action. This could be as simple as running a game that it is being Rust, maybe have a leaderboard and update the leaderboard with the proofs. It could be offloading a heavy computation. You could run an ML model and take a decision on chain only if, I don't know, GPT-1 agrees with that decision. Of course, big models are not going to be provable right now, but a small model should. You could be maybe something which has where users try to predict the outcome of something and present ZK proofs. And I'm sure that you can imagine many other applications, and as time passes and ZK technology improves, you will be able to prove bigger computations, but you will still need somewhere to verify, even more if you want to use all the data in Ethereum. So for those who haven't seen it, like the documentation, you can find it in docs.alignlayer.com, and you can find the link in our GitHub repo. Everything that we do is open source, so you have everything there. And you will see a small guide that will allow you to send a proof to Align, verify it on chain. We can do it really quickly because it doesn't take much time. But this, of course, is more to play around with the application, and not how your application is going to look. So I can run the commands. I already have Align installed, but I can install it. Try to screen, but this will tell you to source Align, so it appears in the terminal. You can download an example proof. In your application, you will need to have some way to generate a proof. This one has been pre-generated. You can send a proof to Align with this command. This is going to be, your proof is going to be grouped together with other proofs or batched together. So the cost gets split between all the users of the network. And this is going to take around 3 blocks, the whole process. I can just open another one. Sorry about that. Sorry about this. I'm very bad with all the screens. So as soon as this gets verified, I'm going to show you, but this will give you a result that your proofs have been verified successfully. This works, and it's nice to see the interaction, but of course your applications is going to be more related to the blockchain. So you will actually want to take some action with the proof verification, not just to verify. If you want to do that, I'm going to show you a little bit how that can be done. So you have an example here that I highly recommend you to take a look at it. And the code is published And the idea of this application is that the user answer questions and will submit a secret proof that they have answered them correctly. And if they have answered them correctly, they will receive an NFT. We made this first category just to test the application, but if you actually want to see how it's done, you can read this section that is integrating Align into your application. The code is open source. You can see it here. And what the contract does, that you will have to do something similar, is it receives the data that Align gives to you when you send a proof and it gets verified. That is all of this. Your contract needs to verify that the program is the one you're expected, because this is a network that receives many types of proof of many users of many programs. So you need to check that the program is the one you expect. I will show you in the documentation how that is being done, but is this F commitment here that is a check. Well, this calls Align. As you can see, our contract, and if all is good, it means a token. It means, an NFT. And that's it. On the contract side, it's quite straightforward. It's not many lines of code. And once you have that, you can do something. In this case, we are giving the user an NFT, but you can do other stuff. So check this guide and ask if you have any questions. Later, it should explain you how to use it. Then you might face a situation where you actually need to use output for the program. Let's say you offloaded the computation and you want to use the results and make sure that the results are verified. That's what we call in ZK cryptography the public input. So it sounds a little bit strange for people who doesn't come from ZK. But the public input can be any input or output of your program that can change with execution, or that it is like public information. So let's say you are calculating a very big Fibonacci, or you do some expensive computation and get to a result. That result in ZK, we actually call it a public input, even if it is an output of the program. I don't want to dive too deep as to not generate more confusion, but the idea is that any data that you need to use is going to be a public input. And so you have a smart guide on how to get that public input and how to actually do something on chain with it. And for your application, that it might have some Rust code, or you will have to interact with a line, and you might not want to use a CLI all the time. If you check ZKRust, if you check ZKQuiz, it doesn't ask the user to use a CLI. You have our SDK. Our SDK is written in Rust, and it has all the commands that you need to interact with a line. In particular, you can submit proofs. That's this code here. And you can do other stuff that we are adding to the documentation, but you can also see it in ZKRust. The most important thing is usually submitting the proofs and then verifying that they are okay. And here is much more detailed documentation of the SDK, and you have all the commands, including the verification of the proof, other stuff that you might find useful. That's an overview. There are some details that might be worth mentioning. If you are using a testnet, you don't need to pay for the proofs. That means that you don't need to farm Holesky Ethereum. All the testnet is running in Holesky. In the typical flow, you will pay to our service, include the proof, but you don't have to. Right now, you will just receive a warning, hey, if this is mainnet, it won't work. We will never publish your proof if you don't pay. But in the testnet, you don't need it. And yeah, then that's an overview. You will need to pick a verifier or a prover to do this. And right now we are supporting NARC. If you want to code the circuits in Go, you have support for the clock 16 backend and for Plonk. And we also have SP1 or X0. We will probably deploy Shoal by the end of the day or tomorrow, very, very soon. Sorry, Nexus. Some others during the following days, so you will have a couple more added, so you can pick from more proving systems. If you want to have a small overview because you haven't seen it before, you can divide the provers kind of in two categories. Let's say that one are the ones who you write Rust code and you prove them, and that will be in this case X0, SP1, and Nexus. Or you can write circuits by hand if you have used Circon before. NARC is very similar. Yeah, check the documentation of NARC and make a choice. If you have never coded in something that you use circuits before, I recommend more to use the Rust provers because you only need to know how to code in Rust. And that's it. And we also have this a wrapper around all the Rust provers that we call ZKRust. Has some tools to interact with our with a line directly, so that might be easier to use, and you don't have to fight against pinning the dependencies right, because there are many versions of all the proving systems, and they might not be compatible. So you can try it out. It should be very easy to use, and you can use any of the Rust provers through our ZKRust application. Okay, I think that's like a small overview. I can show you now that the proof was verified. It has been verified for a while. One that we said at the beginning. If I call a verified proof on chain, it says that the proof is verified online. This is actually calling the Ethereum RPC, and this is an on-chain operation that you don't need to pay because you're just reading the blockchain, but it's happening on-chain. I didn't show you before, but you also have the Explorer online, and you will be able to see the status of your batch here when you send a proof. They usually go really fast because it only takes 3 blocks for the whole process. For the whole process to finish. But yeah, you will be able to see the status, some data of how many proofs you have in the batch, which are the commitments to the proof, some other statistics, and so on. And here you can see another batch of proof came, it's pending, and it will, in some blocks, change its state. All right. I know if you have any question, maybe Boris, do you think we can dive into another topic? Is something that you are interested in talking about? Do you have any questions?
Thanks, Mauro. I mean, there's some conversation in the chat, and I'm happy to bring people on stage to ask and make this more conversational. If Anon or Ewan wants to come on stage, make the request that I can add you. And yeah, if anybody else who's hacking or thinking about hacking has questions, please drop them in the chat or come on stage. This is a really good chance to ask Mauro questions directly.
Yes, I can start answer like the questions in the chat soon. But yeah, if you want to bring them on stage, it's the same for me.
Yeah.
So let me see. Sorry, I missed them. ZKQuiz is a binary example. What if we want to use points? I don't know what do you mean by points. I want to ask that. So okay, so you have points. Okay. So in that case, if you want to use points, you have to use public inputs. So check out the example of using public inputs. You can output how many points the user got. Bear in mind that if you are doing local proving, the user can kinda just try it again. You won't be able to stop it. But yeah, you can put it as a public input. It will be an output of your program, and you can use it on chain. Give them something and update the leaderboard. Yeah. And yes, I think that was already answered. And yes, the one that the example that you use in inputs is Fibonacci. We are adding a couple more that they will be available for everyone probably by Monday. Yes, you want to ask something?
Alright, so yeah, I was even about to post something related to verifying signatures on chain. I just want to ask, I couldn't find it anywhere in NARC's documentation. Is there a way to verify ECDSA keys? Because I saw a way to verify signatures. I saw a way to verify EDDSA signatures, Edward signatures. I couldn't find a way to verify regular ECDSA signatures. Is there a way, or I don't really get that aspect, to be honest.
Yes, you can use any of the Rust provers to just run the code of create the solves that kind of signatures. I'm not sure if NAR has support for that. If you said that you didn't find, it's probably because they don't support that kind of signatures. Bear in mind that it's probably going to be slow.
All right. So yeah, that's really my only question. I don't really have any other question. So yeah.
Cool. Yeah. With the Rust provers, the good thing is you can import any crate that has been done in Rust, and you can prove it. So of course you have all the signatures and everything.
So for the other people in the audience, I don't know if there's like a show of hands. I am really curious if any of you are currently hacking on something or considering it. You can just drop in the chat. We have a few more minutes, so I'm curious to hear what people are working on. And yeah, just generally, if there's anything we can do to help, if anything isn't clear, we really want your feedback so we can make this as easy as possible for you guys to build cool apps and show what's possible using ZK and using Aligned. So don't be shy.
Yes, I'm reading. You can also try propose ideas. We can check them, see if they are viable, and see someone is going to be trying to build a game. That's cool. Ooh, the randomness question. Yeah, you can make any game that is deterministic, and you can make Tetris with the seed. It's okay. Just bear in mind that the user might be able to kind of cheat and fix the seed, but don't worry too much about it. The problem of randomness, like we can talk about it for a long time, but it's a very complicated problem. But if you are putting a lot of money somewhere, you need to, of course, take more care. If it's just a seed of a small game, it doesn't matter. And you have like criteria, for some cases, like using the block hash as a source of randomness, a block hash as a source of randomness is enough. But if you have a lot of money involved, then you have to remember that, okay, the block hash is not actually random, there is a block proposal, You can bribe the block proposers. It works as a random seed up to some point. Oh yeah, the proof on the Explorer. Yeah, I can show you again. There's also, many games that are fully deterministic. Mario, it doesn't have randomness as far as I know. So that might also help. Not all games rely so much in random.
Yeah, Mauro. So I am actually curious about this randomness question because I didn't realize this was like a limitation of, say, doing something in a ZKVM. So you can't have like a random number generator running inside there, for example?
So the answer is that you can have, but here's the thing. Let's imagine that you're trying to, the user can run, you have so all the randomness needs to have a seed, like some source of entropy. Usually it will be like the time on your computer. If you're just going to generate a scenario for a game randomly, you only have to bear in mind that if the user runs again the application, it's another seed, it's another random, and if they tinker it a bit, like they can change the scenario to one that they like. If this is a simple game, it might not matter. Like if you are going to be doing a betting system, like a casino, and there is a lot of money involved, maybe it starts mattering. The other problem with ZK that's a source of randomness, and you can. This is a very open discussion. It's very common. You can read about it. The other thing is that you cannot prove with ZK that you didn't take an action. Like if the user doesn't want to submit a proof, what are you going to do? Like I cannot force the user to submit a proof. But the user can prove to me statements, but I cannot prove the negative, right? I cannot prove that someone didn't. I cannot prove to someone that you didn't play the Tetris game. Maybe you did and you didn't submit the proof, or maybe you didn't. So that's actually why your system can have some extra logic on the blockchain. And let's say if you didn't submit a proof in 100 blocks or in 1 hour, I'm just going to assume that you are trying to cheat, or you are not actually interested in this, and maybe do something, take an action. But it's something to bear in mind.
Okay, interesting. Lots of fun.
Yeah, if this is a topic that it is interesting for people, we can have a talk about randomness. Maybe it's just fully dedicated to this. It's kind of a side topic on all of this, but it's okay. And I also have sent the proof, and it returns a link on the Explorer. So on the CLI, you can just go and then find it, and here it is. And it sends to you, sends the proof like before, so you actually have it available before it verify. No, not Ethereum mainnet. This is a testnet on Holesky. It will be on mainnet when we go to mainnet, basically in a bit. You can run the VM of the prover in real time and receive inputs and outputs from over the internet, and that can be done, and you are proving that. You have to bear in mind that the non-deterministic part is not verifiable. So let's say that you make a program that has to take a decision based on some incoming connection. There is no way to prove that incoming connection actually happened, and that you didn't change the value and pretended that you received a message through the network. Yeah. Maybe you know, if you want, I'm going like very deep in some topics, but this is a hackathon. Have fun. Like if randomness doesn't need to be perfect. If you find something that is good enough to your case, you can use it, and then we try to polish it. The same with input output. Input output is usually not something very safe. It's like You cannot prove the input-output or the connections with the sockets. You can prove that your machine did something based on something that is external, but you're not really sure if that really happened or if it is a mock, unless you have another machine on the other side. I don't know what's going on that image, Justin. We will need to take a look at the whole code and see. A walkthrough of the development process. I can show you maybe how. Okay, let's think a little bit. What do you mean while development process? It's like the tooling is the first part that you will need is a design, right? I'm thinking how are you going to use a secret proof and blockchain and what do you want to build. The specifics of how to interact with the line, they are all in the documentation. Maybe I can give you something specific. Usually, the flow for a user will be something like they need to deposit some money on a line. They send their proofs, and when they get the data back and the confirmation of that the proof have been included, they can interact with your contract and do something like receive an NFT, get points, or a decision happens in the blockchain. And on your side is thinking, okay, I have this system that can prove things and verify things. Well, what do I want to do with that? It's not, there are many things to align the specifics. The only thing that you need to check is that the proof belongs to the program you are expecting. So you don't get mixed with another user. If you make Tetris and another one is verifying Doom, you want to differentiate the proof of Doom from the proof of Tetris. There isn't anything linking it to you except like the commitment to the program that has been proven. We call that the verification key or F commitment, and there is a small guide on how to get that commitment. So yeah. You then call the verify function of a line with a static call, check ZKRust, and that's it. The verification of an key is sent to a smart contract. No. The verification data is not sent to any smart contract. So I will show you the architecture of it. Maybe that will help. So this is like a very simplified architecture, but the user sends a task to our batcher, and it will receive at some point this what we call align verification data. The only thing that is going to remain on the contract is like a marker root. I don't want to go like too much into the details because we can go, but you don't really need to know much. But the important thing is the align contract has a function that you send all that data that you receive, and it tells you if it is verified or not. And I can show you this static call to align. Or even checker with ZKRust. We can prepare that example. I will try to avoid a live coding section because I have to go. But we can, if you think that will help, we can do that. Sorry, I'm seeing. Yeah.
Drop that in the Hackathon channel here or in the Telegram, and we will answer them if there's like examples you're curious about. We're going to have more support engineering to help you guys along over the next week. But for now, I think we'll close it off here. We're going to have this recording up so you can review it. Of course, Mauro was mostly referencing our documentation, so that's all available for you to take a look. So yeah, thank you all for joining. Excited to see more of your questions. Again, we're trying to help everyone out who's hacking and make this an easy process for you. So if you have an idea you're working on, reach out to us. We would love to chat and help you work on the idea. So with that, happy coding and see you around soon. Thank you again, Mauro.
See you around. Thank you for having me, Boris.
So yeah, I guess we can get started. Really, this is just a Q&A session for Mauro, our head of engineering, to answer questions that different hackathon participants may have or people might have on a technical front when building with Aligned. So I'm happy to bring people onto the stage to ask directly, or you can start dropping your questions in the chat. Yeah?
Yes. While you make questions, maybe I can give a small update on the things I've been doing. But I think probably the thing that you will learn more if you are on the hackathon is that the new guide to build your application, which is now ZKQuiz if you have done it before, but it's now plain in detail all the steps. It doesn't explain how to generate the proof because that's more related to SP1. In this case, but we will add it in the following days anyways, and we will port it to ZKRust. ZKRust will have an update really soon that it will make it easier to use, in particular with the regarding the payments. And if you are interested in using Nexus on Lita, we are expecting them to be live very soon. It might take a bit for the operators to upgrade, but probably by the end of the week or beginning of the next week, it should be deployed. For those who don't know, when on ZK VM proving or like Rust code and prove with ZK, you have different alternatives. Right now we support SP1 or X0. Valida is another one. It works. We can deep dive into it, but it has another mechanism to prove. And the same with Nexus that uses folding schemes and other techniques. So Carson is asking, I'm building AI SNS freedom market we don't change, so can I graph with a line? Okay, I don't know exactly what SNS is, so you can explain to me one, then we can deep dive. If it's like the chain you are planning to use is not Ethereum, then like you want to bootstrap your own like app chain, or is it something that needs to do things on Ethereum? Both things can be done with a line, but it changed a little bit how you should handle it.
Mauro, so there's a question about Kimchi verifier being ready for this hackathon, and I wonder if this is the same person who was asking in the Telegram group earlier about
the
Mina bridge.
So yeah, what do you mean by Kimchi verifier? Like, do you want to verify proofs written in O1CS, or do you want to bridge state from Mina to Ethereum? Proof O1CS. Okay, the first thing is not done by the Kimchi verifier. So right now it's not going to be on this hackathon. I think we won't be supporting that maybe in the future, but not now. So you cannot use O1CS program and just running on Ethereum. On the bridge side, what is happening is that the bridge is running in. Well, first, let me explain you a bit the architecture. How does it work? Align will have, let me explain a bit, two extra verifiers to do the bridge. One is verifying ZK proof, and the other one is verifying Poseidon inclusion proofs that Mina uses. So what we will do is like deploy those verifiers so you can deploy your own contract to bridge the state. That will be up to each application. We won't be supporting our own. We won't be running our own bridge, but you will have the verifiers to bridge the state. Then the question is if it's going to be for the hackathon. I'm not sure. Like, my intuition is that it will be, but it's going to be on testnet by the end of the hackathon. So I will do something. I will ask the team that built the Mina bridge because they were running another network. So what maybe can be done is instead of using the aligned testnet, you use that specific network, and that works. I will investigate a little bit and get back at you while we integrate Mina on the main network. I will write this down so I can get back probably not immediately, but in a couple of days with an answer. Okay. I think like the separate network should be easy to do. Like my only worry is that we have a lot of telemetry stuff. I need to think a bit about it because we have a lot of telemetry and diagnosis tools from the chain to make sure that the testnet is always live. And if something happens in testnet at 3 a.m., someone will wake up and fix it. I cannot assure that those guarantees will be on the other chain because most of the infra to maintain the blockchain is on testnet. So, but let me think a little bit about this outside the call, and I will get back. The other thing is we probably need a guide to how to operate a bridge, and I'm not sure if that is there now. Well, I will check it and get back at you. All right. Another alternative is there is a guide that I don't recommend everyone to use it. That is the infrastructure guide. You will see it in the documentation, and that guide, what it tells you is how to run the local network, and that can also help you in this case. For example, like you could be running your own local network, and if it is for a demo of the Mina network, which maybe it's enough. I will also check that. Maybe I will write that. Maybe they can also use local network integrate. There should be like you have to install like a lot of things sadly to run a line because we use a lot of code in Rust of verifier. We use Golang for the operators because the SDK was in Go. Is in Go. Now there is a Rust alternative, but when we started it didn't exist. And we use a little bit of Elixir for some complementary services. So you end up having to install like a lot of things. I think the Docker, we have like a Docker almost done that will allow you to boot all the network, like with one command. The image is kind of heavy. It is like 40 gigabytes, but it's easier to run. I think it was done. We were trying to have something to download it and not have to wait like 2 hours until you compile. So maybe we will update that infrastructure in the following days as soon as we have like the Docker compose going to be to launch. All right. Any other questions? So this is connecting with the line.
I invited 2 people to come on stage because they had requested, but then they didn't show up. So I don't know if they still are. Yeah, I sent 2 invites, Borromeo and Mega Collins, who are both in the audience still. So if you two wanted to ask you questions, please feel free. Mauro, I wanted to say actually this morning I went through the ZKQuiz, the updated version.
Yes.
And I was able to do it. I had to install
You were able to do it?
Foundry, but I was able to mint the NFT on testnet. And I think the guide is pretty clear. So if anyone wants to play around with that, definitely check it out. I am writing a thread to put on Twitter today on the topic. Now that I figured it out.
Awesome. Yeah. So to be honest, it was kind of bad before we updated. So if someone read like the previous one, now is improved. It was like kind of magical before. It had like tricks that we didn't explain. We don't want to be magicians, not explaining the tricks. Now everything is explained.
I have a question on it, actually, like looking at the sort of the different components, the diagram under the deep dive section. You know, it says the user interacts with the app, but in this case, I guess the app is actually just the command line scripts, right?
Yeah, in this case, the app is where you answer the questions. It's just a command line.
I see. Okay, cool. And then the entire program is written in Rust and proven using SP1, which is also it's all in Rust. And then proof gets generated, sent to aligned. Command line gets the results, checks that it was verified, confirms it with a verifier contract, and then mints. So yeah, nice little article, everyone. Worth checking out, and we will do a thread on this as well. Did I manage to change the questions? I did not try changing the questions. I guess that would require altering the program itself, right?
So if you want to change the questions, you need to recompute the ketchup of the questions. I think that's probably not explained. I'm going to write it down how to change. I'm going to write it down how to change questions in ZKQuiz to be added to the guide. I'm going to make sure that that's the guide. I think it's not. So the thing is, you could like just put in the program like the right questions, and the verifier will verify that they are right. But you will see that we are using a hash for that. Why? Just to at least not have the user go to the Rust code and spoil the answer. That's the only reason, right? Because if not, there's no text. So we use the ketchup hash over the answers. That's the trick, and it's only to kind of hide in the code what's the correct answer. That way, you can brute force it because it's calculated in ketchup, but it's not visible in plain sight.
I see.
If you so I think Mega is saying that he has not been able to mint the NFT. Yeah. Let me check, because we remove like the guide to just mint NFT because it wasn't supposed to be like a guide. Yeah, the NFT doesn't have any value, it's just like an example application, and it was more important for us, for people to build it than to claim it. But it should work. Like, I don't know, like you can maybe rely share just like was a problem, but you should be able to go to the last version and just answer. Mina NFT from Morris. I think they want your specific ZKQuiz NFT, Morris. They don't like that.
One that 4,800 other people have minted. I will say though that the hardest part of the entire process was getting Foundry to work properly, because I didn't have it installed. When I did install it, I guess I didn't reboot after installing things properly with this libusb thing through Homebrew, which I had to install in the first place. So I had to install Homebrew, and then this libusb, and then eventually Foundry, which then created the proper key store folder so I could do all the steps. But until then, I was getting confused because I could generate new key pairs, but then it wasn't going into the key store. Foundry will.
Okay.
So
Yeah, that's actually a good feedback. We can avoid using Foundry actually. So for example, the key store, there are some wallets that are like MetaMask. I'm not sure if MetaMask, so don't take it for granted. But I remember there are some wallets that allow you to export like as a key store.
okay.
You might be able to do that, so that might be useful for someone doing applications if you don't want to use Foundry and you want the user to be able to create a key pair. There are some wallets that allow you to export it in the same format that we use. We can double check. I'm gonna write it down like a small note.
Mm-hmm.
Write down alternative. Create.
Something in general I'll let you write this down.
Yeah. And I'm not sure if you're using Foundry for another thing, maybe for another cast command, but I don't think so. Yeah, and if it exists, like the SDK should be enough to do everything. So the user shouldn't need to install Foundry. That's a good feedback.
Yeah, something that I'm generally curious about, and I feel like most of the hackathon teams are probably not at this stage yet, but something I feel like I'm really interested in seeing how people approach this is the integration of things like Wallet Connect, so people can connect to your app and make a transaction to play a game, for example, or use some service which under the hood is using a line to verify proofs. But yeah, I don't think we have any documentation for that kind of stuff yet, but that's more just app development stuff anyway, I guess.
We did that at some point, so let me check that. The only issue that you have is that you need to generate the proofs and you cannot do it in the browser yet. That's not the limitation of a line, that's the limitation of the provers. The provers don't work in the browser. But if you have a proof, you should be able to sign it with MetaMask. That's something that some projects are doing. Yeah, I will write down to share the code. Share the code to sign MetaMask. We have some code in JavaScript. It's kind of hard coded, and yeah, it's just like a sketch. But you can sign a proof and send it to the batcher. If not, it's a good maybe project inside a project or a small project to use in this hackathon. Make the example application of how to integrate with MetaMask, how to use it. We can merge it on testnet. That's useful.
We have a guest.
We have some echo mega live, but yeah, hello. Oh no, I didn't want him to run away. You guys just mute when yourself when you talk. It's okay. Like when you don't talk, sorry.
Yeah, I don't know where they disappeared to, but yeah, just I wanted to add on to what Mauro just said. I mean, if any teams are building out this kind of basic integration components for using Aligned in your apps, that's something that we would love to see collaboration between teams. So if you're building something that you think is useful more generally, please do share it. Like we're watching what everyone's talking about, and we are making notes of who's contributing in this kind of way. So that would be like super, super helpful if you do figure out some of these building blocks for using Aligned in your projects. And you can also reach out to us and discuss it beforehand. But these are the kind of contributions that we really want to see in the community. So don't be shy.
Yeah, other thing, for example, that some teams are working, and it's cool if you share it. Maybe you can share the same piece of code or work together. It's like delegating a proof into a server, which is so the user can do something in the browser, send it to a proving service, and it gets proven, and that's more user friendly. And yeah, that's probably something very common that everyone needs to solve. We don't have any guide, and we don't have code, so that's other thing that others are working, and you might want to. Yeah, that's usually just in case because that can be a rabbit hole. That's hard to do when you want to do actual ZK with privacy. But if not, it's not that complicated. It's a problem when you want to do privacy, because if you are going to send to the server all your data that you want to prove, it's not very private, right? You are revealing all the information to that server. But if you don't care about privacy, and for most applications, I don't think you will care a lot, like you can just send all the data and it gets proven.
I dropped a question in the chat, Mauro, that I'd posted on Slack, but since we have a few minutes, I figured I'd maybe ask here.
Oh, yes. It's like the person who asked this question here.
No. This question's from Ewan, Lord Ewan, on Telegram and Discord, but I can pass the answer on to him, or you're not in that group, which is why I posted it in Slack. So.
So he's writing a server to submit proof. So the question is that you don't. I mean, like the verification data object is a response from the batcher when you already submit like the proof VK public inputs. I wanna double check the code anyway, so just in case that I have. Okay, no, sorry. Okay, yeah, I see it now. It's a bit confusing because we have aligned verification data. Okay, we should change that so it's less confusing. How do you parse it? The official way to use this is with we serialize it with. Sorry, give me a second. I forgot like the name of the serialization protocol. It's not being called, is serialized. Is CBOR. They are not serialized with CBOR. Technically, like the network supports JSON, but it's more like a fallback. We usually just use CBOR for everything, and I'm not totally confident that the batcher supports JSON anymore. I think it doesn't. So you need to use CBOR. It's called like CBOR. And then you have to have like the same format. We picked that one because it's like JSON, you know, it's like a very standard way to serialize thing. If you use a JSON, so you use characters, right? And that makes all the data to have the size double. If you use CBOR, you get like at least half a compression by a factor of 2. And more because it's more efficient. But it's a more efficient way to serialize. So that, sorry, if that might not be the question, it's hard to understand. So if it was about serializing, that's the question. Yeah, not sure if that answers. We should ask the person.
I'll share what you just said, and then we'll take it from there. Thanks, Toro.
All right.
Yeah, that's all they said. And
hello, is that, I don't know if do you have any question? So
Emery here, he joined us during the community call last Wednesday and mentioned that he was working on a project for the hackathon. I don't want to keep you too long, Mauro, because we're almost at the.
No, it's okay.
But let's see if Emery has a question. I think he was working on. I think a DeFi thing. I have some notes. He can correct me.
All right. Here he said he's saying that he doesn't have any question.
Hello. Okay, well, if we don't have any more questions, Mauro, I don't want to keep you too long. I know got a lot going on. It's very busy over at the office, so I'm gonna let you go. And thank you again for joining us, and everyone else who joined. Thank you for the questions. Keep dropping them in Discord and in the Telegram. We're here to discuss ideas and help you however we can. Your feedback is very valuable. So hope to see you in a forum sometime soon.